Okay, let's start with number 29 on this one. So with number 29, we are looking for some holes in the graph. I have holes in a graph when I have a factor on the top that will cancel out with a factor on the bottom. So let me start by factoring these things. So up there on the top, I'm going to factor with 7x and x. And then my only factors of 5 are 5 and 1. And I need them to add to give me 36. So I'm going to put my 5 here and my 1 here so that I have 35 plus 1. And they're both going to be a plus sign because of that one right there. Okay, on the bottom, again, I've got 7x and x. And now I need factors that will give me 15 that will subtract to give me 32. So I'm going to use 5 and 3. So that I have a positive 35 and minus 3 to give me that positive 32 right there. All right, so here's my factor right here that's going to cancel out. So I know that's a place where this thing cannot be equal to 0. So I'm going to have a hole where x is equal to negative 5. So I'm going to use the opposite sign. Now to find that hole, I'm going to use what's left of my equation. So don't plug it back into the original equation, but plug it in right there where we have kind of what's left after you cancel that out. All right, so let's go into that. So 7 times negative 5 plus 1 on the top, and on the bottom I'll have 7 times negative 5 minus 3. So let's see, that's going to give me negative 35 plus 1 is going to give me negative 34. And on the bottom, I'm going to have negative 35 minus 3 gives me negative 38. And I'm just going to reduce that a little bit. So my negative over my negative becomes a positive. And that's going to give me 17 over 19. So this graph's going to have a hole at negative 5 and 17/19. All right, back to my eyes. If I'm going to multiply these together, I'm going to use FOIL or distribute. So I'm going to start with 4 times 7 is going to give me 28. And then 4 times negative 4i gives me minus 16i. And then right here, I'm going to have positive 63i. And then I'm going to have negative 36. And then I times I gives me I squared. But again, remember, I'm going to change that I squared into a negative 1. And so that's going to give me 28. I'm going to go ahead and move this to the front as a plus 36. And then right here, I've got 63 minus 16. So that's going to give me 47. Oops, my equal sign there. So plus 47i. And then finally, I'm going to combine these like terms right here. So 28 plus 36 is going to give me 64. Plus 47i. So always be sure you change those I squareds into negative 1s and just kind of get them out of the way. All right, on 31, we're working with this APERT formula right here. They tell me to use that. I'm going to invest $6,000, so that's going to be my principal amount. That's the amount that we invest at the beginning. I've got an interest rate of 5%, so I'm going to change that into 0.05 so that I can use it in my formula. And because we're compounding continuously, that's how I know to use this APERT formula right here. And we want to determine the balance, so that ending amount is what we're looking for after 2 years. So my time's going to be 2. All right, so my ending amount is going to be equal to my $6,000 with e to the 0.05 times 2 power. All right, so I'm going to put all of that into my calculator. So in my calculator, I'm going to put in, let's do the 0.05 times 2 first. And then e is right above the natural log button right here. So I'm going to do second e, and I'm going to raise that to the 0.1 power. And then I'm going to multiply that by my 6,000. We're talking about money here, so let's go ahead and round to 2 decimal places on this. And I'm going to go ahead and round that up to 3 cents. You can either round or truncate on that. All right, on 32, we're talking about a natural log of the cube root of e. Anytime I'm in a natural log situation, I'm going to change that into a log with a base of e. And I'm going to change this right here into e to the 1/3 power. I'm going to go ahead and set that equal to x, because that's what I'm looking for, is what is this thing equal to. And now I have something that I can move around. So I'm going to say that my base is e. I've got an exponent of x, and it's going to be equal to all of this together, so e to the 1/3 power. So in this case, if my bases are equal, then I know my exponents have to be equal as well. So x is equal to 1/3. All right, on number 33, I'm in an exponential situation and I'm kind of stuck. Anytime I feel that way, I'm going to change into a log. So I'm going to have the log with a base of 10 of 42 is equal to x. So back on my calculator, a log base 10 is the log button. That's what this represents right here. So I'm just going to use my log button right there, and I'm going to type in 42. And it tells me to round to the hundredth place, so that's going to be 2 decimal places. So that's going to be 1.62. So normally we round to 3 decimal places, but be sure you read the directions. All right, on 34, we're going to write this as a single logarithm, or we're going to condense. So I'm going to start by taking my lead coefficients and moving them up into my exponents on both of these. So that's going to now be the log of x cubed plus the log of x minus 2 to the 4th. All right, and then in the last step, I know that I can condense addition with logarithms with multiplication. So that's going to give me the log of x cubed times x minus 2 to the 4th. And now I have a single logarithm written, and we can leave that multiplication just exactly the way that it is. All right, and then finally 35 looks a little bit like 32. I'm going to start by changing that natural log into a log with a base of e to the 8th. And again, I'm going to set that equal to x so that I have something to use for my exponential. So to change to an exponential, I'm going to say that's e to the x power is equal to e to the 8th. So all of that kind of goes over here. And again, if my bases are equal, then my exponents are going to be equal.